Hello my dear students, I am B.S. Pandey. Today we are in lecture number 24. Lecture 24 of chapter 2, same section, electrostatics. My dear students, today we'll start the lecture with the capacitance of isolated spherical capacitor like Earth, and then we will start the concept of dielectrics after finishing the force between the plates of capacitor. So the capacitance of isolated spherical capacitor. The example will be the perfect example with the Earth. Okay, so the capacitance of isolated spherical capacitor. Okay, my dear student. Here, the isolated capacitor, what does it mean? The isolated capacitor, we are having here the one cell over which the charge is being given. Suppose the radius of this cell is R. To find the potential, students, we need the important thing, it is the potential. So have you studied the potential of cell of radius R if charge Q is given on the surface? And the answer is yes, that we have studied. The potential we have studied is the KQ over R. Do you remember, my dear student? Yes. Now to find the capacitance, we know that for capacitance we know Q is equals to C times V, and Q can be written as C times V. Already we have calculated the KQ by R. So we have, and the Q will be cancelled out. So the C is equals to R by K, and this is the capacitance of isolated spherical capacitor. This K is 1 by 4 pi epsilon naught. It means this capacitance can be also written as the 4 pi epsilon naught R. Okay. You will find the formula like the 4 pi epsilon naught R. It is the capacitance of isolated spherical capacitor. You can write the R by K also. This is the the very simplified formula. Okay, my dear students. The number of questions you find to calculate the capacitance of Earth. As you know, the radius of the Earth will be 6400 kilometer, and you can convert into meter. Epsilon naught value you are having already, so you can find the capacitance. Okay, if you are finding out the capacitance for considering the Earth as a sphere. Now, the next question we are moving, the mathematical derivation that is very important for the board. It is to find the force between plates of capacitor. As we know that the capacitor is made up of the two metallic plates, and one is positively charged and the another is the negatively charged. Might be that we have filled between the plates of the capacitor the dielectric or any insulator, but due to the positive and negative charge, if this is positively charged and this is negatively charged, both will attract each other and there will be force. Of course, it is filled with the dielectric so that they cannot meet each other, but there must be some force. We are going to find out here what will be the force between the two plates. Okay, and the question will be find mathematical derivation for the force between two plates of the parallel plate capacitor. Okay, so I'm writing here the force between plates of capacitor. Force between plates of capacitor. Okay, my dear students, this is two plates of capacitor. Here One is connected with the positive terminal of the battery and another is connected with the negative terminal of the battery. As we know, the positive charge over here and negative charge over here. We know that the electric field will be established between the space of capacitor, and this electric field is nothing but the E. Okay, my dear student. But this electric field, do you remember the formula of electric field? This electric field, it was in between the plates E, it was sigma by epsilon naught. Okay, but if I'll ask the electric field at either plate, if I'm asking the electric field at this plate, then what will be the answer? At this plate, remember, this plate will not contribute the electric field at this plate. At this plate, electric field will be due to the positively charged plate. Remember, the sigma by epsilon was the electric field due to both the plates. This equivalent electric field was sigma by epsilon naught. This positive charge will give electric field this direction. Negative charge will also give in this direction. And then the two net electric field was sigma by epsilon naught. For one plate, we have calculated the electric field. It was sigma by 2 epsilon naught. If we are finding the electric field over this plate, so the electric field will be sigma by 2 epsilon naught. I hope you are getting. This is the electric field, but in between the plates of capacitor. This is not on any plates of capacitor. Again, I'm telling you. If we have to find the force, then the first thing in our mind is coming, then who will experience the force? And the answer is the charge on the capacitor plates. Charge on the plates will experience the force. As we know that the charge which is placed in electric field experiences a force. Of course, it is the charge and it will experience a force. Okay. But if it is placed in electric field, of course, it is placed in electric field of the first plate. So this is not the electric field. We should cut it out. Now we are going to find out the electric field in which either plate is placed. So the field developed on one plate filled on either plate, you can write either plate can be written as the E is equals to what will the answer? Sigma by epsilon naught or 2 epsilon naught? Yes, sigma by 2 epsilon naught. This is the field. Suppose we are finding the field at this point at P. So electric field will be this one, and this particular the charge are placed over here. So this charge will experience a force and the total charge will experience a force that will be the actually force between the plates. Okay. So here force we can write is equals to Q times E. It is the total charge of the plate, charge on the plate. So it is the Q times E. It is sigma by 2 epsilon naught. Now we can continue to simplify this one as, my dear students, force will be written as this F is equals to Q times sigma can be written the Q by A 2 epsilon naught, or it can be half Q square over A epsilon naught. If I'm not wrong, this would be the equation. Yes, and this is the force between plates of capacitor, which is very, very important. Q square by twice A epsilon naught. This is the force between the plates. Could you write this force in terms of electric field also? Could you write this one? And I say yes, you can write, and this will be F is equals to half times Q. This Q and QA by epsilon naught will be the electric field between the plates. Remember, this electric field was how much? it was sigma by epsilon naught or Q by A epsilon naught. So this Q by A epsilon naught, here the 2Q, that is the Q square, Q by A epsilon naught can be written as the E. So Q I have taken out and this is E. But remember here E is not the electric field on any plate. That is not the EP. This is the electric field between the plates of capacitor. And this is another formula of force between the plates of capacitor. So this is a very simple formula. I think this is not very tedious or the very tough. Now, on the basis of this formula, you can solve number of question, my dear student. Okay, now we'll move for the next and the very important topic. It is the dielectric. I'm rubbing this one, kindly note down. So now we'll move for the dielectric. Okay, dielectric, we'll study dielectric and polarization. Dielectrics and polarization. Actually, my dear student, when Michael Faraday was doing an experiment for the capacitor, he found that the several materials increases the capacitance, that is the capacity of capacitor, and that all the material were insulator. And he introduced and he explained that a dielectric, which is insulator itself, dielectric plays, if we place a dielectric between the plates of capacitor, then capacitance will increase. It was studied by Michael Faraday. Then he introduced a dielectric and did an experiment. He find actually, yes, capacitance was increased. So today we'll study the dielectric, and then after we'll move for the how this dielectric increases the capacitance. Of course, if this dielectric material will increase the capacitance, it will decrease the potential, because we have studied already by decreasing the potential only we can increase the capacitance. Okay, now my dear students, dielectric, you have to remember the dielectric are nothing. Dielectric are insulator, which can, if you want to write, then you can write, my dear students. Dielectric are insulator. These are insulator. Okay, insulator like water, plastic, mica, etc. will be the dielectrics. Okay, so dielectric are insulator which can induce the charge on its surface to produce induced electric field. Remember, this is the insulator. Okay, this is the insulator which can induce the charge. Insulator which can induce the charge. Okay, why it is inducing the charge? So it can induce the charge on its surface to produce induced electric field, to produce induced electric field, induced electric field. Dielectric means one way we will supply the electric field, and dielectric will create another electric field. That's why it is called a dielectric. One electric field we will supply and another electric field will be induced by the material. That's why this is called the dielectric. Okay, but the important thing we have to study here, in which direction this dielectric will induce the electric field, whether in the direction of applied electric field or opposite to the applied electric field. Answer is dielectric induces electric field opposite to the applied electric field. It means the net electric field due to insertion of dielectric between any space or between the plates of capacitor, the net electric field will decrease. Okay, that we will study. Remember these points. This point will help you to study. Now we'll study how many dielectrics are there that we have to study. So you have to study two types of dielectric. One, it is the polar dielectric, and another is the non-polar dielectrics. Okay, the one is polar dielectric, and another is non-polar. Okay, dielectrics. What are the polar dielectrics and non-polar dielectrics, my dear students? Polar dielectrics are those whose center of mass of positive and negative charge. Remember, polar dielectrics whose center of mass of positive and negative charge do not coincide. If this is polar dielectric, then positive and negative charge separated by some distance. But non-polar dielectrics, in which positive and negative charge, that is the center of mass of positive and negative charge, coincides. Of course, if for the polar dielectric, positive and negative charge, center of mass of positive and negative charge do not coincide, it means even in absence of electric field, we are not supplying any electric field, it has some dipole moment. Of course, the dipole moment will not zero, but here the dipole moment will be how much? Zero, because here the positive and negative charge are coincides. If positive and negative are separated, of course they will have some net dipole moment, otherwise here net dipole moment will be zero. What are the example of this polar dielectric will be like N2O, H2O. Okay, and for this will be you can take the example as H2O2, okay, etc. There are a number of polar and non-polar. Remember, this polar dielectric, what is the important actually? The polar dielectric has permanent dipole moment. It has the permanent dipole moment. This is not zero, permanent dipole moment. Okay, permanent dipole moment. But net dipole moment, this is the permanent dipole moment, but there is no one atom. There are a number of atoms in a dielectrics. So whether we are having the net dipole moment, we will discuss. But I am talking here the individual, due to the one atom, the dipole moment will be not equals to zero. Now this is the net dipole moment. It has the permanent dipole moment, but in absence of electric field, remember, in absence of electric field, in presence of electric field, the whole material will not have the net dipole moment, whatever may be the polar or non-polar. The net dipole moment, remember, net dipole moment of the dielectric substance will be zero. Remember, okay? How we will study. Now, my dear students, dielectric constant. The next topic we will study dielectric. This is very important. Dielectric constant. This is also called relative permittivity. Relative permittivity. It is represented by K or epsilon R. Remember, this is the dielectric constant represented by K or epsilon R. This is the dielectric constant. What is this dielectric constant, my dear student? So dielectric constant, you can write the definition. It is the ratio of force between two charges in vacuum to the force in dielectric medium. What I have told, K or epsilon R, whatever, is the force between two charges in vacuum. In vacuum, the ratio of force between two charges in vacuum to the force between that same charge placed at the same separation but in presence of medium. Okay, which medium? Dielectric medium. Could you write here? It is as, if Q is the charge, then in vacuum E naught, in medium as EM. Q will be cancelled out. Then we can write here as K is equals to E naught by EM. What does it mean? In presence of medium, or within the medium, within the substance, the electric field will be E naught by K times. This is the very important. This is the very important. So remember, EM will be equals the E naught divided by K. Electric field will reduce if you will place a dielectric between two charges. Then electric field due to each charge, or the force between the two charges, will reduce. Remember, this is the very important relation you have to remember. We will use this relation directly. Now student, another relation that you have to remember, must remember, is this one. If E is the electric field and this E naught is also the electric field, then you can write as, if one charge which is placed at the K from here, K is equals to 1 by 4 pi epsilon naught for the vacuum, and electric field is the Q by R square divided by 1 by 4 pi epsilon m for the medium, and Q by R square, because separation is same. What will happen? All the things will be cancelled out, but 1 by epsilon naught divided by 1 by epsilon m, and we can write then it is as K is equals to epsilon m divided by epsilon naught. Remember, my dear students, this relation is very important and you have to remember this relation directly. What it, epsilon m is equals to K times epsilon naught. Okay, epsilon K times epsilon naught, that is the epsilon m is equals K times epsilon naught, and this epsilon m, which is the permittivity in presence of medium, that will be K times, that K be also written at the epsilon, relative, okay, and this epsilon naught. Everywhere, wherever you have been written or the used in electrostatics, the epsilon naught, that will be replaced by, due to presence of dielectric, that will be replaced by K times epsilon naught. Directly you have to replace this epsilon naught by K epsilon naught. If dielectric is present, you have been asked what will be the effect of dielectric, then find out in formula where is epsilon naught written. Replace this epsilon naught by K epsilon naught. If K will be below, then that will be decreased by K times. If above, then if in numerator, then it will be increased by K times. Remember, replace epsilon naught by K epsilon naught. So in this way you can write the epsilon. Now my dear students, we will study how the electric field actually changes between the plates of capacitor. How the electric field changes? Suppose we are taking the new topic we are starting over here, dielectric between plates of capacitor, or you can write here the electric field due to dielectric. due to dielectrics. Okay, suppose this is a plate of capacitor and we have filled over here a dielectric. Okay, and placing a dielectric. If I place a dielectric and here the plus or minus potential, plus and minus potential is being given, what will happen? This particular dielectric slab here, suppose when field is not given, when E external is 0, here the case we are studying here, E external is how much? 0. In this case, the atom of dielectric oriented here and there, okay, in this way, and positive and negative charge are arranged by their own way. Positive, negative are arranged. Here, remember, there will be dipole moment of individual atoms. Dipole moment of individual atoms. If they are polar dielectrics, there will be dipole moment of individual atoms. Even in absence of electric field, we have not given an electric field, but the netted dipole moment P net will be how much? 0, even in absence of external field. Field is not given, but net dipole moment will be 0, since dipole moment is a vector quantity. Suppose one dipole moment in this direction and another dipole moment in this direction, so the net will be cancelled out to give 0. So the number of atoms and they are oriented in such a way, the net dipole moment of either a polar dielectric actually giving the net dipole moment, non-polar already have the net dipole moment 0 in absence of electric field. Now what will happen if we will supply the electric field? If we'll supply the electric field, that will be the very interesting things. Okay, under application of applied electric field, this all the dipoles are arranged, that is aligned due to the electric field. This is plates of capacitor. Now field is switched on. Field is switched on, and this is the dielectric slab. Or 11. Now plus and minus of only few atoms I am representing here. You can understand the plus and minus. Minus and plus. If it is plus and minus, then minus will come this side and plus this side. Plus this side, minus this side. Applied electric field, it is E external given in this direction. Okay, E external we have given in this direction, E external. Due to this plus or minus, you can see there will be a electric field. It is E induced. Okay, E induced electric field will be inside the dielectric material, and the net electric field due to insertion of this dielectric will be what? Here E net, that is due to medium, will be E external minus E induced. Okay, so this will be the net electric field due to the this particular dielectric slab. That is, in presence of medium, the net electric field in medium, or due to presence of medium, it will be E external minus E, and this electric field is reduced. Okay, this will give you a very interesting formula, that is for the induced charge. What will be the charge induced? Remember, as you are applying electric field, here the charge is being induced, -1, and here the +1. Otherwise, you were you had no concept, no idea whether here the positive or negative charge is being induced. But now here a pole is arised. Okay, that's why we will study the polarization. It comes from the pole arise, and we'll study the polarization. So induced charge and the concept of this net electric field, how this decreases and by what factor it decreases, and how we will use, will study in next lecture, my dear students. Okay, thank you very much.